Partial fraction decomposition, part 4, a unique solution and a top-heavy fraction. Welcome to Mark's Math Methods. So here's the answer. Example 1. I want to convert negative 3x squared plus 2x plus 4 over x cubed plus 2x squared into the sum of some fractions. And we end up with 2 over x squared and negative 3 over x plus 2. Do you know what happened to the x denominator fraction? Because our denominator should have been x squared, and x plus 2. The x and then the x squared because of the multiplicity. Do you know what happened? Pause the video and see if you can figure it out. Let's see what happened. So we're going to convert this into the sum of some fractions. So our denominators are x squared, and x plus 2. So we use placeholders. And then just like before, we're going to clear fractions. Doing the same thing we've been doing all along. And now I'm going to multiply everything out on the right side, just like we've been. And then we'll look at the x squared terms. We'll look at the x terms, constant terms. Those are our 3 equations. So we can use 3 equations, 3 unknowns, matrices in our calculators. So our x squared is 1, 0, 1, negative 3. Our x is 2, 1, 0, 2. And the constant is 0, 2, 0, 4. Use RREF, and this is what we get. Notice the 0 for A. That's why there is no x denominator term, because the numerator was a 0. All right, let's look at this one, example 2. So we want to convert x to the 4th minus 5x cubed minus 9x squared minus 21x plus 12 over x cubed minus x squared minus 12x into the sum of some fractions. Notice that the numerator is to a higher degree than the denominator. So this is top heavy. Okay, so here's what we have to do first. We have to use long division to reduce it. So we'll go ahead and take the denominator, divide it into the numerator. So we get x. We're going to subtract, which changes those to addition. Bring down. So if you don't remember how to do long division, this would be a good thing to go back and review. You could probably use synthetic just as well. So we end up with x minus 4 plus negative x squared minus 69x plus 12 over the denominator, x cubed minus x squared minus 12x. So now the fraction is no longer top heavy. So now after the long division, we have the quotient, which is x minus 4, plus the remainder over the divisor. So that's negative x squared minus 69x plus 12 over the x cubed minus x squared minus 12x. Let me throw in the integration symbols so we can see why we're doing this. just a refresher. So integrating the x minus 4 is a piece of cake. But now we get that complex fraction at the end there. So we're going to do just like we did before. We're going to factor the denominator and continue factoring. So our denominator is now x minus 4, x plus 3. So we're going to set it up like this. Something over x minus 4, something over x plus 3. We'll do all the work. I'm not going to show it. But we end up with negative 1 over x, negative 10 over x minus 4, and 10 over x plus 3. So the integral of that whole huge, horrible, top-heavy fraction is the integral of x minus 4 plus these three little fractions. And this is much easier to do, which is why we do partial fraction decomposition and how we can handle the fraction that is top-heavy. Just do long division, split it apart, quotient, and remainder over the divisor. And then that one you may have to do again as needed. I hope the presentation was helpful. Thumbs up, subscribe, comment. And if you have any problem types you'd like me to demonstrate, there's my address.